Yeah. So let
So,
me
Rob,
see.
yeah,
Uh, do I see if I can share Keynote? So let
yeah,
me just check. I should be able to share. Can you still see the presentation?
yeah, yeah. We
Okay,
see
good.
our slides. Hmm.
So um, I guess this is what caused me to think this was a good idea to present. So two things I think. One is that somebody sent me the dynamic land, and I thought so. I'll come to that in a minute. This is Bret Victor's uh, work that he's been working on for a few years now. I'll explain who Bret Victor is for those who don't know. Um, Also, we get questions, and for instance, Jimmy on the mailing list maybe a few days ago asked what's your favourite three things of Forth, and often I find myself trying to explain what is good about Forth. Right, it's a popular topic for us guys, I guess, because people you've got this very esoteric language, sometimes seen well, it's an old language, and but the sort of good bits about it. Um, it's tricky to explain the whole the reason why it's good and although there are pieces in other programming languages and other environments, it doesn't quite work as well as it does in Forth. So what I want to do here is sort of draw some parallels between Bret Victor's work and and Forth, and also there's a whole philosophy behind Forth, um, that even where Forth doesn't exist, that philosophy is still important. So I'll try not to take forever because, as everybody know, I can talk forever, right? So, so let me get on with it. So Bret Victor, um, he is a guy who's worked at Apple. He's a user interface designer, but he's also a programmer, a computer scientist, and he's also got qualifications in electronics. Um, So I put a couple of links so you can look him up. He's also got his CVs. He's put some key things there. He's quite an interesting guy. He got famous uh, for a presentation, which yeah. Um, so this is off his CV with the various pieces of research. He got famous for a video called Inventing on Principle. I think that was the thing that really, and so I'm going to explain this a certain amount of irony with me talking about a dynamic environment with a slide deck, but I think I can do it anyway. So there's a couple of slides on Inventing in Principle. So he demonstrated a bunch of places where just writing code doesn't give you a good enough way of exploring what's actually happening. So some problems are problems that we know what the problem is, and we know what the solution is. And in those domains, there are some advantages to perhaps using more static techniques and static analysis and things like Rust with very, very tight controls. But in reality, um, a lot of problems we don't really know what the problem is, even for things we've solved before, because often what we're doing is new, and we don't really know what the solution is. Um, and I mean, I think Chuck Moore, sort of operated this way. He discovered what the problem was with building a prototype, and then built the actual solution. So this particular example from Brett, he basically he's got some code, and he wants to. It's a tree. It's a tree drawing algorithm, and he basically can click on the variables in the text window and just scrub up and down with them to alter various parameters. And and this isn't the first. I mean, this um, created a bunch of other examples. Like there's a guy that writes a lower IDE called Zero Brain Studio. He implemented this live coding technique, and people have taken a look at this. From a Forth perspective, I quite like tweaking variables on the fly and getting immediate results. He also talked. There was also a bunch of other things in this video. It's worth watching. For instance, on the bottom right, there is a sort of a spice image, but you can see the waveforms at the various nodes. And he even had an example with the voltage and the resistor waveforms live. Um, it got a piece of top right is a piece of code where you can see the values of variables, and this sort of visualization thing I see happening Forth. Peter Chikaki ask, how do you visualize memory? And I find myself writing words, or even if I'm writing in C, writing functions that are run from like a Forth interpreter to see how data structures are formed, right? Um, on the top left, it was a sort of video game example where he was trying to figure out how high and how long the jump should be to make it feel correct. This sort of dynamic operation. So it's worth watching because I think although he uses a lot of visual metaphors, this whole visualizing and interactivity is something which I see a lot in the Forth community as well. So this is my sort of summary, interactive in terms of, you don't disconnect from the underlying machine and do a 20-minute recompile in order to tweak something. So we've got things like deferring Forth, which I see a lot of people asking about. I also in some of my Forths I got patch. Somebody was talking about maybe it was maybe it was Peter actually talking about having a large amount of RAM and having your whole Forth running in RAM because there's a load of tricks you can run. Totally agree. I've often had patch instructions, even for subroutine threaded Forth, where I can re-vector a whole bunch of interaction. I mean, these things do exist in static domains. So I always remember Marcus Pearson Notch on Java pausing Minecraft and patching the behavior of skeletons in that game as on an early video. But it's quite crude. The same is true of Visual Studio patch and continue, right? It's very fragile. There was only limited things you could tweak. You hadn't really got this sort of underlying environment. And even in Python, I don't see the Python people using that. There's some things like PyDev that can reload files. It's again restricted, but I don't actually see Python developers altering live programs in a way that perhaps we do in Forth. Interactivity, this whole fast cycle time, stepwise refinement, editing things on the fly, incremental testing, and the whole I mean, we're seeing a few examples even today of people adapting the environment to small and large targets, that sort of flexibility. These are the sort of parallels I see. So um, it's also how do we make these things more accessible and how do we visualize this stuff? And I'll come back to that maybe in a minute. The other video that's worth watching from Bret is this future of programming. He pretends to be I can't remember, 1960s or 1970s computer scientist, and actually talks about things that some of them we don't even do today that are good ideas. It sort of he uses overhead slides. It's a whole thing to do with it, and it sort of really questions that: are we really programming in the right way? Are we heading the right direction? So that's quite an interesting video as well. The thing I wanted to get on was this dynamic land. So he's got they've effectively almost eradicated the computers in a way, or pushed them into an environment, right? So I guess in our normal lives we've got things like Alexa that you can ask questions of, but it's not really computing in the way that we do it, I guess. This dynamic land is having on table surfaces an interactive environment, right? So the snippets of code, you see that thing in the folder on the top left, it's got snippets of code, and the older version of dynamic land uses these color markers you can see on the right picture to recognize pieces. And you can put the pieces down and it simulates that live on the table or on the floor or on the wall. This is you doing a wind simulation. And then on the bottom right, you can see a card that he's put down that causes the computer to project this. Now, there are these sort of projection systems, but this isn't it, right? This, which I'll come to in a minute. So he's got cards that maybe can play videos, but the video actually was of it interacting with real world objects, right? So as well as having markers for recognizing things, it will recognize objects and projects things onto them. So this is a way of people interacting with a computing environment live in the world, right? Um, and there's a whole bunch of examples that people have generated, music with different music cards and sort of wind tunnel simulations. And this is a community computing environment, that right? So it projects stuff on walls, on floors, this sort of stuff. Um, the interesting thing is all these are small snippets of code, right? The whole sort of word philosophy and Forth springs to mind with this, small, powerful pieces that you can build up and put together. Um, and people are solving whole bunches of problems with this sort of stuff collaboratively in a sort of open environment. But the sort of interesting thing is a couple of things. One is that these programs they're aimed not just at computer scientists to write them; they're aimed at normal people to write them. You can also edit them live. So on the bottom right, use the keyboard to edit a piece of code inside the computer. So they're not using laptops or PCs to edit the code; they're editing it as they work on the problem, right? Um, it doesn't need to be pieces of code. They've got demonstrations with icons, uh, running effectively a program that you can hand draw uh, icons and it follows a particular sequence. So you can build up any sort of interpreter to run code in the environment if you like. Um, and then one of the things he points out is these pieces of code are quite small because the world is really the simulation environment. It's not if you do something inside a computer, you have to build up the complete world. They find that these things are quite small because they're dealing with these sort of environments. And people are putting these pieces of code together, and you can take pieces of code and combine them in unexpected ways. Um, and they've got whole bunches of stuff, interactive stuff. It's not just, although the current implementation uses projectors and cameras, and I'll show you the picture what they look like in a minute. It's really sort of interacting with the world that's important here. They've got a whole bunch of stuff. Um, the one interesting thing is the operating system for this isn't written in a piece of code in a laptop somewhere or computer. The operating system is written in it's called Real Talk, and it's written in Real Talk. So they've got a bunch of rules, and the OS itself for the whole system is on pieces of paper on the wall, right? Small snippets of code that come together. And they work on it in the real environment. And they've got a whole bunch of different rules that anybody can look at. And their idea is to sort of push this into the community and get community, it might be scientists or they've had school children work on, be able to understand the environment. This isn't a product. This isn't something you can download. They want to be careful of. They want to build up a community of computing in the same way that mathematics and language to a large extent, at least the lower layers are owned by people. You can teach anybody how to, add up numbers. You don't need to go through somebody with a PhD in mathematics. So this is sort of ownership of these computing. And so they've got all these they've got this sort of stuff where they're sort of interacting with the machine live. And they've got this thing at the bottom is a visualization of a data structure, right? So they've written a lot of visualizers, so that they're loading some sort of data out of computing unit somewhere, and they can see it and edit that data live. These things showing, so this keyboard has got to line up to that piece of code, so they're editing that piece of code in order to alter the behavior of the system in the environment. I don't remember what I was going to say about this slide. And they built up this, it's not just this group that's building sort of these programs. They've had a bunch of people come into these spaces and build things on a whole bunch of topics, from weaving to molecular cloning to thermodynamics to rhythm to color to painting. They've got a whole bunch of examples on the video. And these, I won't read through this. The bottom, they went for non-profit status. So that this PDF at the bottom is very interesting, right? So this is sort of local community built up, self learned and taught, not downloaded. Uh, I knew people would be sort of interested in the what technology they're using behind. So they've got these sort of lamp stands which have got lights in them as well, but they've got cameras and projectors. Uh, Brett himself points out that it's not, you can use, there's other things inputs into the real world. You can use anything. Uh, but they use a lot of these. They actually build them into lampstands so they could take them out to shows and exhibitions and get people working on them in those sort of spaces. Some of these lampstands have got a computing unit in the bottom. They're not overly specific about what it is. Some of them are just tethered to sort of a central one. So they can use several computers, and some of them will be sort of dumb that will be tethered to another lampstand. So the first video is only 6 minutes long. It's worth watching. And then there is the 2020 progress report has actually got a whole bunch of interesting stuff about visualization. I've got a few examples here. So they've got a visualizer that shows them heap and stack memory, right? So this is sort of interesting from a, if you ever try to debug a memory leak, they're tricky, right? Generally, Forth systems aren't big enough, but as soon as they start to become big because you're doing a whole bunch of stuff, maybe like IP or file system work, you can end up with complex problems. The one of is another picture of that file system. The one on the bottom right is this is how it links together different. So if you put different pieces of paper together, how it actually links, the system links together internally via these intermediate tables, and they've got a visualizer for that as well. So they can explain how to people who aren't necessarily computer scientists, how when you put one piece of paper down, it finds what it should do with another piece of paper or another code fragment. So this is my sort of examples of why I think it's similar to Forth in a bunch of ways. There's a whole, although it's not, there's a whole bunch of parallels here, but again, it summarizes down to sort of interactivity and the ability to extend it, and not be hidden behind, somebody says the code base for Windows is like a gigabyte or several gigabytes of source code, right, in Windows, right? Well, how is that editable by anybody, right? Even Linux, that where you can download the source code, it takes you hours to build, and I don't know, months maybe to make a change in Linux, right? It's not an environment that is really commoditized to everybody. So these are sort of the things that, although they're very different projects, there's a bunch of goals that are sort of aligned in that way, which is why I thought it was interesting. I'd say watch the videos, right? I mean, the videos probably do a much better job of explaining than I do. Um, there is a bonus video. This isn't by Bret Victor, which actually mentions Forth in this video. He talks about static languages and C++ and Rust and long compile times versus sort of dynamic and visualization. He starts off talking about punch cards and Fortran. So for a lot of us who have actually seen punch cards in operation or fail miserably with punch cards, it starts off interesting. It's a very funny video, but he mentions that some systems have a high cost of failure. This was the one slide that sort of struck and people think that static typing and long compile times and verifiers are the way of doing that, but obviously NASA has sent stuff up in Lisp and Forth and patched bugs while off world. So that's sort of an interesting video as well. So that's my it's basically to try to get you to watch a couple of videos. That was my entire objective. But I think it's interesting seeing these sort of alternative systems of computing and people's alternative views, because a lot of them try to solve the same sort of problems as I think we are already solving in Forth.
Mm-hmm. Right. Thank you very much. Very inspiring. And yeah, are there any questions to Rob? Comments?
Yeah, you're going to leave any links for all those things, the PDFs and videos?
I'll upload the PDF with all the links to the Forth 2020 group straight after this.
Great, thanks.
Mm-hmm.
No, that was really interesting, Rob. I've called them up while you're talking about them, so I've got them all open here, and I'm going to have a real good look at. Real food for thought, that one.
Yeah.
What have you done anything with it at all yourself, or?
Yeah, I mean, he's got some of the old stuff. He's got some of the old stuff on his website, but the dynamic land itself isn't there. But I think it's just I played with for his first stuff the live coding stuff. I played with there's a guy that writes Zero Brain Studio that he actually added some features for us, but which is a Lua IDE. He's got live coding there. I've played with that. I think it's tricky in a lot of languages. I tried it in Lua to get it to reload pieces, and it's just it's much harder than it is in Forth, right? I could patch a word in Forth or defer a word in Forth, and even in a running system with other threads, I can get the live system to change. And a lot of languages really fight against this, right? I mean, certainly you can't do it with static language, but even the dynamic language like Python and Lua and the like, it's really hard to get that sort of dynamic interactivity where you can change bits of code on the fly. And I like the whole dynamic land where you're just playing with bits of code. And you can flip a piece of code over so it can't see it anymore, and it stops running that process, or it stops running that fragment of code. And it's just this tangibility, this touchability of code, right? This is sort of the sort of really interesting piece for me, and this is what attracts me to Forth, you see, because you can touch the code there and then and modify it, and it's the whole system's live, you know.
Yeah.
Yeah. One remark: it doesn't help if the PDF is uploaded to for 2020 because 99% of the Forters or inhabitants cannot access that.
Well,
So
I'll paste the links as well as a separate item.
Yeah, that's a good idea.
Yeah, we had the AM radio already in the previous talk, so making the use of more senses to get insight. And I remember that in the old DOS days there was a program called X-Ray that was capable to real-time display part of memory. And using this for force programming was also interesting because you could just display the portion of the stack and the return stack, and you could see the program actually running in real time and seeing how it manipulated the stacks. Very much similar to the LEDs and toggles that we saw earlier.
Yeah.
So it's this hands-on and this extension to additional senses. I think that is quite appealing.
Some old machines could run programs right in video RAM, so you saw literally the characters or the bits, if you had a bitmap video, flip over as your program ran.
Somebody famous said that show me your code, I won't know how it works. Show me your data, and I'll know how it works. I can't remember. I'm paraphrasing it badly, but being able to visualize and see the way data flows through a system live is nothing better.